So 10.3 is called the unit circle. We're going to do this section in 2 different days. So our focus today is to get some definitions of the unit circle. I'm going to show you how to create the unit circle. And then tomorrow I'll go over how we use the unit circle. Okay? So the first thing we have to know before we construct this ourselves is about a unit of measurement called radians. So earlier when we were talking about the mode and how mode can be in degrees and radians, I compared degrees and radians to 2 other units of measurement. Do you guys remember what I said? Yeah, okay, so I said the radians and degrees, they're both how you measure angles, just like with Fahrenheit and Celsius, that's how you measure the temperature, right? So they both measure the same exact thing, they're just different units, okay? Are you guys pretty good at converting Celsius to Fahrenheit? I was going to say, is that Yetta is, because Yetta, do you use Celsius?
Yeah.
Okay. But like if I said it was 30 degrees Celsius outside, would you guys know what that means? I would have to look up the conversion myself. Like I don't have a great frame of reference. Yeah.
It's about 95.
Okay, yeah, about 95 degrees. So, so Yetta knows that because she's familiar with it, but some of you are looking at me like, yeah, I have no clue. That's just because it takes practice. So it takes being familiar with it. It's going to be the same thing with radians. What we need to know about radians is it's a unit of angle measure based on the arc length. And you did find arc length in geometry. Does that term ring any bells? It really is just the distance of part of the circle. So when you did this in geometry, you would find this R, that would be your arc length. Maybe a little bit. Okay. So 1 radian is, in this case, equal to your theta value. But a lot of times when you're talking about radians, you're thinking of 180 degrees. So 180 degrees is equal to pi radians. In this class, the Algebra 2 Honors, we're mostly going to be dealing with pi with our radians. But next year when you go to pre-calc, you will be dealing with some radians that don't necessarily have pi in them. So this is where writing your degree symbol is going to be really important. Okay? So 0 degrees in radians is going to be 0. 180 degrees is going to be pi. Okay? So 0 degrees is equal to 0 radians. So will you guys add that in there? Okay, and 180, it tells you right here, 180 is equal to pi. So we're just going to put pi underneath that. So 180 and pi are the same thing. Right? Now notice they do say pi radians, 2 pi radians. A lot of times when you are looking at the radians, it doesn't have it written there. So we're really going to rely on that degree symbol. Okay, so the circumference of a circle with any radius is 2 pi r. So if you have an angle that represents 1 complete rotation, that's going to be 2 pi radians. So 360 degrees is a full degree, 1 circle. 2 pi is also going to be 1 circle. Okay, and you can use that fact to convert between radians and degrees. So I know you guys wrote this down last week. You're going to multiply the number of degrees. It says by pi radians over 180. We're just going to multiply by pi over 180 degrees. Okay, that's if you're going from degrees to radians. Now, if you're going from radians to degrees, you're going to multiply by 180 over pi. Okay, how many of you are in chemistry this year or have taken it in the past? Okay, so you guys do a lot of conversions in there, right? You've done the moles with conversions and then they cancel out. This is the same type of thing. All right, so that's what we're going to be using today. So example 1 is to convert each measure. Oops, sorry. I need my blank one. Okay, so the first one that you guys wrote down is 60 degrees. So some of you may have already done that because you had the conversion rate. That's fine. So if you've done it, you can check. And if you haven't, we can do it together. So you guys had -60 and 250. Okay, so if you start with degrees, you're going to convert to radians. So degrees to radians means you're going to multiply by pi over 180 degrees. So just like with your conversions, when you look at the units, the degree and the degree are going to cancel out. Okay, and then when you multiply, you're multiplying the numerator by the numerator. So this is -60 pi over 180, and then you just reduce. So something like this, I would expect you to reduce without a calculator, because what goes into both 60 and 180? Yeah, and 60 does go in there. Without a calculator, I would just expect you to realize that 10 goes into both, right? So you can cancel out the zeros. And then what's 6 over 18? What does that reduce to? 1/3. Yep. So this is -pi over 3. And you don't have to put the 1 in front. So that would be your final answer. Okay, so 6 goes into itself once, goes into 18 3 times. All right, and then let's do B. So again, you're going to multiply by pi over 180. Okay, and what goes into both 250 and 180? 10. So then you have 25 and 18. Does anything go into both of those? No. So we're going to keep it as 25 pi over 18. And that would be your final answer. All right, and then part C, we're going to be given the radians. So sometimes when you are given this, it'll say 2 pi over 3, and it'll say radians with it. Other times it might just be -7 pi over 2. So anytime you don't see the degree symbol, okay, then it's going to be in radians, which you did write a little note here. You should have a little note here that says if there's a no degree symbol, the unit is radians. Did you guys get that from last week? Underneath, it says if there's no degree symbol, the unit is radians, and often radians will contain pi, but it doesn't have to. Okay, so often radians will contain pi. But it doesn't have to. Okay, so like I said, with what we're doing this year, you are going to have them with pi, but next year you'll step it up and you'll do some without. Okay, so what are we going to multiply 2 pi over 3 by? So now the 180 goes on the top, pi is on the bottom. Okay, so if we were to multiply straight across, what's 2 times 180? 360. So this is 360 pi over 3 pi. Okay, now pi divided by pi is just what? 1. So those are going to cancel. And then what's 360 divided by 3? 120. So if there is no degree symbol, the unit is radians. So that means you need your degree symbol. So I didn't take off any points on the last quiz if you didn't put your degree symbol, but I would take off for this. Okay, so you have to show that it's the degrees, because if it doesn't have a degree, it's considered radians. Okay, and then we're going to multiply this one by 180 over pi. Now when you're doing this, if you want to cancel out the pi's right away, that's perfectly fine. Okay, if you don't want to multiply across. In fact, if you were doing this without a calculator, you're not going to want to multiply 7 times 180, right? Instead, let's just simplify. What's 180 divided by 2? 90. So then let's just rewrite this as 90. Now I can do 90 times 7, because 9 times 7 is 63. So I just put the 0 on it, keep it negative, put my degree symbol. There you go. Okay, so your homework tonight is mainly that. Okay? Is doing your conversions. Okay, and now we're going to talk unit circle. I'm pumped. First day of the rest of your life. The unit circle. So like I said, the unit circle is very important for not only the rest of what we're doing this year, but also next year if you're taking pre-calculus, the unit circle is a big part of that. Calculus, trig, if you're doing trig, or the college algebra course. Okay, all of this stuff is going to come back around. So the unit circle is a circle that has a radius of 1 unit. Okay, so the radius is 1 unit. Okay, and then for every point P, so every point x, y on the unit circle, the value of r is 1. Okay, so anytime you do the value of r, it's 1. Which means if you have theta in the standard position, we're going to write out the sine, the cosine, and the tangent. This is something that we talked about before. Remember, if you have theta in the standard position, we drew this triangle. Here's your theta. This would be r. This is x. This is y. Do you guys know why x is always on the bottom here and y is always on this side? Yes. Yes. And the y-axis. So the x-axis is horizontal, right? So x is horizontal. Y is vertical, so this part's vertical. Okay? All right, so your sine value, your sine of theta, which we know is the opposite over the hypotenuse, would be what over what? Y over r. Good. Have we written this down before? Yes. We're going to do something different in a minute? Yes. So the cosine is what over what? Yes. And then do you guys remember what tangent is? Yes. Great. Okay, so we've talked about this before for sine, cosine, and tangent. Now, the new thing that we just introduced is that the radius is 1. So for the value of r, that's 1. So that means this is the same thing as y over 1. What's y over 1? Just y. Okay, so what that means is the sine of theta is equal to just y in the unit circle. Okay, so your y is your sine of theta. Okay, and then your cosine is going to be equal to what? X. Okay, and then tangent is special because tangent doesn't have an r in it, but see how it's y over x? Well, what did we just say y was? Y is equal to the sine. So the tangent of theta is equal to the sine over, what's the x? Cosine. That's your y over your x. Is sine over cosine. so on the unit circle, there are going to be points that are going to follow this format. So think about all the points that we've graphed before, right? When you're graphing a point, a coordinate, it's always written as what, comma, what? X, comma, y. So all the points are x, y, right? Well, all the points on the unit circle, if you have your x is related to cosine, and y is related to sine. So every point on the unit circle is going to represent cosine and sine. And this is something that we're going to dive deeper in tomorrow. But this is going to be important, an important relationship, okay? All right, when you are done with that, I want you to flip it to the back, and you should all have a strange-looking ruler on your desk. You guys have done a really nice job at not playing with those, so I appreciate it. Okay, I'm going to show you how to use this today. Does anybody not have one on their desk? Okay, so this is a protractor, a different kind of protractor. The unit circle, all of the points on the unit circle can be found using our rules for special triangles. So that's why we did that warm-up today with the A, B, and C. Okay. So what I'm going to have you do is on your protractor, see how they have the numbers down here? I want you to line it up so the line goes directly on the 30. So I'll show you that again. So you have this line this up so it goes directly on the 30-degree mark. Okay, and then once you have that, the center, you have to find the center of your angle here. Please use pencil for this part. Okay, and then we're just going to line that up as best as we can. And we are going to make our first angle. Okay, so just hold that part down there. Alright, and then I'm going to use two different colors because we're going to be doing degrees and radians today. So starting here, your degree is 0 degrees, so will you put that there? Okay, and you just made this, and what degree was that we just used? We just did 30, so that's 30 degrees. We just made a 30-degree angle. Okay, and there are only special places on the unit circle. That doesn't mean that the other degrees don't exist. It just means they don't have an exact value like these do. Okay, so the next angle, if we're looking at our special triangles, can you guys guess what the next angle would be? There's one before it. 45, yeah. So 45 is the next one, and then you guys were right, 60 will be the one after that. Okay, good work. So 45, let's make it 45. We're going to put it at the center. And like I said, the construction of this is really important. I know it might seem that I'm going kind of slow at times, but there's going to be a lot of connections that we're making today. Okay, and then this will be 45 degrees. And then when you are ready, you can do the 60 degrees. So line that up. Put it at the center. And you have just made all of the special points in the first quadrant. Okay, so you have 0, you have the 30 degrees, the 45 degrees, the 60 degrees. What's this one at the top? Yep. What's this one here?
180.
Yes. What's one full time around?
360.
Yes. We're going to wait on that one for a minute. Okay, so it's 0, 30, 45, 60. Okay? Now, everything else is going to stem from this first quadrant. So if you can memorize this first quadrant, which I'm going to show you some tips and tricks for that, you can make the entire unit circle from that. Okay? So the first thing we're going to do is we are going to extend values from quadrant 1, which you can label quadrant 1 now with your Roman numeral. We're going to extend them into quadrant 3. We're going to do this in a very particular way using things that you guys already know. So this is 0 to 180. Do you guys know why that is? Think about this angle. You guys remember in geometry what this is called? No, because you'd have to have 2, but you're on the right track. And it does start with an S. It's a straight angle, right? A straight angle measures how much? 180. Yep. Okay, so what we're going to do is we're just going to extend this using what we know about straight lines, okay? So just line it up with your 30-degree line, and we're just going to extend this into the quadrant across from quadrant 1. Do you guys know what it's called? Yes. And then don't stress out if it's not exact. I promise it'll still look good if you're using your straight angle. Okay, and then we're going to label this line using what you guys know about straight angles. So if this is 30 degrees, here, from here to here is 30, and you go a straight line, how can I find what this is? Nope, don't subtract them, but add them. Yep, because from here to here is 30, right? So you go 30 degrees, and then you add 180. Okay, I also think of it in terms of like a semicircle, right? So a semicircle is 180 degrees. So what's 30 plus 180? Yep. So this is going to be 210. So based on that, let's do the other lines. So we can extend all of them, and because it's a straight line, we're always just going to add 180. So I'm going to draw both of my straight lines, and then I'm going to add them. Okay, so I want you to label them. Okay, so then you have 210. What's 45 plus 180? 225. Good work. And then 60 plus 180? 240. Okay, and you guys have just done quadrant 3. So quadrant 1, quadrant 3. Okay, the next quadrant we're going to do is quadrant 2. So in quadrant 2, all of the lines are reflections of these. So what we're going to do is we're going to do that 30 degrees again. So find 30 degrees on your protractor. And instead of lining it up at the initial side, I'm going to line it up on the negative part of the x-axis. Okay? So we're going to line this up here. And then the next one I'm going to do is 45. Well, actually, how could I find out what this is if I'm 30 degrees from 180 here, but backwards? We could just subtract 30 from 180, which is 150. And then I'm going to do the same thing with my 45 degrees. So I get my 45 on my protractor. We're going to put it at the center. Okay, and we can think of that in the same way. So if this was 45 degrees from 180, we just do 180 minus 45. What's 180 minus 45? Yes. Good. Okay, so I did 30, I did 45, which means the last angle I have to do is 60. Okay, and then if you do 180 minus 60, you get 120. And I'm actually going to show you a new way to do quadrant 4, okay? So I want you to look at the patterns that are forming between these angles. So to go from 0 to 30, 30 degrees, 30 to 45 is how many? 15. 45 to 60 is 15. And then 60 to 90 is 30. So this goes 30, 15, 15, 30. Does the same thing happen here? 30, 15, 15, 30. 30, 15, 15, 30. So if I go 30 degrees from 240, 240, this is going to be what? 270. Okay, so then why don't we just extend these lines like we did last time, but instead of adding 180, let's just follow the pattern. 30, 15, 15, 30. Does that sound good? Okay, so we're going to extend all those lines. How are you guys doing so far? Hanging in there, processing. I'm operating under the assumption that you guys have done nothing with the unit circle up to this point. Would you guys say that's accurate? Okay, so all we did is extended those lines, and now we're just going to follow the pattern. So if I follow the pattern, 270 plus 30 is 300. And then 300 plus 15, 315. 315 plus 15, 330. And then look, if I added 30, I'd be back there at 360. Yay! And that is quadrant 4. So we have quadrant 1, 2, 3, and 4. We have all of our degrees on there, all of the degrees on the unit circle. Okay, do you guys have any questions for me about the degrees? Okay, feeling good?
Is it an emergency? Because we're going to do the radians, and that's usually kind of hard. Okay.
All right, so the next thing we're going to do are the radians, okay? Now, the radian part, we're going to use some counting. So, some people try to memorize the entire unit circle. You do not have to invite that stress into your life, okay? As long as you know how to count, you know the first quadrant, you can count your way through the entire unit circle, okay? So the two that we need are really going to be the 30 degrees and the 45 degrees as radians. Do you guys remember how many radians we said 0 was? It's 0. Okay, so 0 is going to be your radian value here. Okay, do you guys remember what the 180 is? No? That'll be the 360. The 180 is pi. And then the 360 is the 2 pi. Yeah? Okay, so what we have to know is if it's the 30 degrees and the 45 degrees, I'm actually going to start with the 45, okay? You guys trust me for a minute? You don't have to write this part down. So if I want to convert 45 degrees into radians, you don't have to write this part down. Remember what I just taught you? What would I multiply by to make that into radians? Pi over 180. Okay. So to do that, I'd have to divide 45 divided by 180. Do you guys know how many times 45 goes into 180? You can count how many 45-degree angles there are in 180. How many 45-degree angles are there? Yeah, 4. 1, 2, 3, 4. Right? 45 degrees goes in there 4 times. Okay, so this would be pi over 4. Okay, so that's what I want you to write here, is pi over 4. Bless you. So what we're going to do is we're going to use pi over 4 to fill in what we can. All right, this part is really important, this part and the next part, just so that you can make it without, because you don't want to do all these conversions, right? You could, just take you forever. So for pi over 4, see how it's 1 pi over 4? Again, you don't have to write this part down. We're going to write it down in a second. So if this is 45 degrees, is 1 pi over 4, I can go a second 45 degrees, and guess what this is going to be? Yep. What is 2 pi over 4 reduced to? Which would be, yes, 1/2 of pi, which would be pi over 2. We are going to write that there, but I'm just going to show you the rest of this. Now, if I go another 45 degrees, this would be what over 4? 3 pi over 4. And then if I went another 45 degrees, that would be 4 pi over 4, right, which reduces to pi. So if I went another 45 degrees, that's not 45 degrees. If I went another 45 degrees, that would be 5 pi over 4. And then I'd have 6 pi over 4. And then I'd have 7 pi over 4. All I have to do is just make sure I go back and reduce those. Okay? So you guys already told me this one would be pi over 2. So you can write pi over 2 where 90 degrees is. Pi over 2. Okay? And then 3 pi over 4. Can you reduce 3 pi over 4? Nope. 3 pi over 4. Again, you're going 45 degrees because that's what we're counting with. And then 4 pi over 4, does that reduce? Yep, and we reduced it already. So then we'll do 5 pi over 4. Don't need to reduce. 6 pi over 4. So what goes in both 6 and 4? 2. So if you divide both by 2, you'll get, yep, 3 pi over 2. But again, remember, this was 5 pi over 4. This was 6 pi over 4, so this one has to be 7 pi over 4. And then 8 pi over 4 reduces to 2 pi. Okay, now look at this. Everything that is a multiple of 45 degrees has the 4 in the denominator, right? So if you follow this line, they both end in 4. If you follow this line, they both end in 4. We reduce these and they both end in 2. Okay? So the next one we're going to do the 30 degrees. Okay? And 30 degrees, if we reduce that, right, 30 times pi over 180, what's 3 over 18? Yes, so this is going to be pi over 6. So here's 1 pi over 6. Where's your 2 pi over 6 going to be? Yes. So do you understand you keep going however many degrees? So this is 30, so go another 30. And then 2 pi over 6 reduces to pi over 3. Okay, so 1 pi over 6, 2 pi over 6. Then I'd be at 90, which is 3 pi over 6. Where am I going to be next? 4 pi over 6 at 120. What does 4 pi over 6 reduce to? Yep, so 2 pi over 3. All right, so I'm going to let you fill in the rest of those, and then we'll check. Okay? So I just want you to keep counting 30. Keep counting 30, and then reduce anything that you need to. That means you're on the right path, right? 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. 6 pi over 6 is pi. Oh, did you skip that line? That's easy to do. Yeah. Okay, 7 pi over 6. 8 pi over 6 is? So if this is 8, this one's 9, and we already did that one. So now we have 10 pi over 6, which reduces to, 5 pi over 3. And then this one would be 11 pi over 6. Now, is there anything that you guys notice about these denominators? Look at each quadrant. 6, 4, 3. This one goes 3, 4, 6. 6, 4, 3. 3, 4, 6. See that? Now, if you were to follow it, 5 pi over 3, if you were to follow it across, does it have the same denominator? 5 pi over 3, does it have the same denominator at what's across? Is that a fluke, or does it happen every time? Every time. Okay, so that means if you're filling in the unit circle and you put like this is something over 6, but this is over 3, okay, that doesn't match up. Okay, so they do have to match up there. Okay, what other radian questions do you guys have? Okay. We are going to be using them, but right now we're just going to do the construction. Okay? All right, so now the next thing we're going to look at on the unit circle is every single place you have a point. Okay? Every single place you have a special point. Okay? And so far we have all of our degrees, we have all of our radians. What we're going to do now is label the points. Okay? So this point here, remember that the radius is 1, okay? So if you were to just graph this in your XY plane, sorry, I know it's not showing up great. If you were to graph this and the radius is 1, what would this point be? No, if this is just a length of 1, what would the point be? 1, 0, right? Right, because the x goes first. So this point would be 1, 0. What would this point be? 0, 1. What would this point be? And what would this point be? 0, negative 1. Guess what? That's exactly what they are. Okay, that's exactly what your points are. And again, it's because the radius is 1. So the length of this is 1. So this is 1, 0. Here, this is 0, 1. This point is negative 1, 0. And this point is 0, negative 1. Okay, because the radius is 1. All right, so the next thing is we're going to find all of the points here. You don't have to write this part in, but remember last week we would find theta and we would make the right triangle once we found the point. Okay, so if we did that here and we said this was our x and this was our y, if this was with 30 degrees, this would be 30. Does this look like anything we did for our bell work today? Yeah, it looks like which one? Looks like part C, right? So for part C, what was our x, what was our y? Yeah, our y was 1/2, our x was root 3 over 2, so guess what? Our x is root 3 over 2, our y is 1/2. Okay, those are directly related to the unit circle. Okay, at 45 degrees, that was our 45, 45, 90 triangle. What was our value for x for our 45, 45, 90? Root 2 over 2 and root 2 over 2. Yeah, you're thinking of the 60 degree one. The 60 degree one, our x was 1/2, and we had root 3 over 2. Okay, now I want you to notice a few patterns here. What are all the denominators of those points? 2. Okay, so we have to remember that. A way to remember what order these go in is if you take the square root, they go in numerical order. So see how this is 0. Okay, so what comes after 0? 1. What's the square root of 1? 1. Square root of 2, square root of 3. So it's root 1, root 2, root 3. Okay, you just simplify that. Now see how this one, the 0 is first? Then it goes in that order. Root 1, root 2, root 3. Okay, now as long as you know this, I said you could figure out any other quadrant. That's because these are reflections. So when you're in quadrant 1, your x and your y, if you go right and up, in quadrant 1, do you have positive values or negative values? They're both positive, right? The x is positive and the y is positive. So this is positive, positive. Okay, in quadrant 2, what is negative, the x or the y? The x. So this is negative, positive. Okay, and then quadrant 3 is y is negative. What about x? Think about it from here. So are you going left? Yes, you're going left and you're going down. So it's negative, negative. And if you're in quadrant 4, yep, x is positive, y is negative. Okay, so positive, negative. Okay, so all we need to do is reflect these points here. Okay? So if I were to reflect this point into quadrant 2, I have the same values, 1/2 root 3 over 2, but which one becomes negative? The x value. Yep, the 1/2. So it's a negative 1/2 root 3 over 2. Okay, for 135, this is the reflection, except now it's negative root 2 over 2, and then positive root 2 over 2. This one is negative root 3 over 2, positive 1/2. Okay, so what I want you to do right now is I want you to finish that part. So do the reflection in this quadrant. The x and the y are both negative. In this quadrant, the x is positive, the y is negative. Okay, so I want you to do that right now. So you have all your points up.